YouTube channel. Today we are going to continue talking about vertex form, but we're going to switch it up a little bit. We are going to talk about what we do when we're given standard form, so that's this, and we want vertex form. Let's remind ourselves what vertex form looks like so we kind of know what the goal is. So we're going to try and take this and make it look like this, and then we can graph it using symmetry like we did yesterday. Let's start with, we already have an example here. All right, so the way that we are going to do this is we are going to use completing the square. Yes, you heard me. It's coming back. So we're going to use completing the square to make vertex form. So when we are completing the square, remember that our leading coefficient, so our A value, needs to be 1. Luckily for this one, it's already 1. So the next thing that we're going to do is we're going to look for the completing the square constant. Half of b, so that's going to be 4 squared. Now, in the past when we completed the square, we added 4 to the left side and the right side. Today we're going to do something a little bit different. So let's take a look. We'll get y squared, or y equals x squared plus 8x. Now, because I'm creating that perfect square trinomial, I'm going to add my 4 squared right here. Because then right here, we have our perfect square trinomial that we'll be able to factor. And then we can't forget, we also have a plus 14 on the end here. Now, we can't just add numbers to equations willy-nilly and change everything. So, because we added 4 squared, we now need to subtract 4 squared. So really, we got a net 0. We added 16, right? Added 16, subtracted 16. So we did not change the equation, we're just kind of manipulating it. All right, next step. In the yellow brackets here, we have a perfect square trinomial. That means it's going to factor to x plus 4 squared. That's the point of completing the square. We've made a perfect square trinomial. Plus, we've got to do this in our calculator. 14 minus 4 squared. Well, I know that's 16, so that's actually going to give us negative 2. And now, this looks like this. This is our vertex form. So now we can use that and graph it using symmetry like we did yesterday. So our vertex is going to be negative 4, negative 2, 1, 2, 3, 4, 1, and 2. Let's draw in our axis of symmetry. Let's choose a point and plug it in. So negative 1, no, negative 2. That's pretty close, right? So if x is negative 2, well, let's find out what y is. Now, we can either plug it into this or the original equation because they're really the same. I'm just going to use this one. So negative 2 plus 4 squared minus 2. Negative 2 plus 4 gives me positive 4. Positive 2 squared gives me 4. Minus 2 is 2. So negative 2, 2. There we go. Then we're going to use symmetry. So I'm 2 away. I can go 2 the other direction. There's our parabola. All right, I have 2 more examples for using completing the square to turn this into vertex form. I'm not going to graph these other ones because there's a whole video on that. So I just want to show you manipulating these equations. All right, so we have standard. We're going towards vertex in case we need a reminder what the goal is. Here is our general form of vertex form. We need to complete the square. When we complete the square, our leading coefficient needs to be 1. So our leading coefficient is negative 2 right now. So that means I need to divide everything by negative 2. So the left side, I'm just going to leave that as y over negative 2. This guy is just kind of going to be along for the ride until the very last step. Then we'll get x squared. Positive 16 divided by negative 2 gives me negative 8x. Negative 33 divided by negative 2 will give me positive 33 over 2. If it doesn't divide, you can just leave it as an improper fraction. All right, now we need to complete the square. So we look at our b value, and we take half of that. So half of negative 8 squared. So our completing the square constant is going to be negative 4 squared. Just we'll leave it like that. All right, next step, we'll get y over negative 2 equals x squared minus 8x. I'm going to add my constant here because now I've created a perfect square trinomial that I can factor. And then we have plus 33 halves minus negative 4 squared. So we added our constant here, and we subtracted our constant here. So we're at a net 0. We didn't change our equation at all. All right, next step, the y over negative 2, just along for the ride till the very end. This is a perfect square trinomial, so it factors into x minus 4 squared. On the outside here, we just have to do this math. Now, negative 4 squared, we should know that's 16, right? So we can just do 33 over 2 plus, minus 16, and you get a half. So plus 1/2. All right, so remember, this is our goal. We're trying to get vertex form. We're very, very close. The only thing that we need to do is get this y all by itself. So this is y divided by negative 2. So to get rid of that, we've got to multiply by negative 2. Whatever we do to one side, we've got to do to the other. So you multiply by the number you're dividing by, and that cancels out, right? So we'll just be left with y. Now remember, this is our goal. We really have two terms here. The x minus 4 squared is one term, and the 1/2 is another term. So you can think about it as distributing. So we're going to distribute the negative 2 here and distribute the negative 2 here. Instead of multiplying that negative 2 in, we're just going to leave it out front because that's our a value. So negative 2 x minus 4 squared, and then we have a half times negative 2 gives us negative 1. So now we're in vertex form, and we could graph like yesterday. But like I said, I think you got enough practice on that one. All right, the last one. This one looks a little intimidating, but once I show you, it's really just one little extra step. Other than that, it's exactly like the other ones that we've done. So we have fractions here. I don't love dealing with fractions, so I want to make these all whole numbers. Luckily, we have common denominators. So what I can do is multiply this whole equation by 7, because that will get rid of our fractions. We'll just be left with the numerators. So that'll be 7y equals negative 3x squared minus 12x minus 12. So now we're kind of at this point where we started last time. The only difference is we have a 7y out here, but again, we'll deal with it at the end like we did here. All right, now we have this. We need to complete the square to transform our equation into vertex form. So our leading coefficient needs to be 1. We're going to divide everything by -3. So we've got -7/3. Y. The negative was on the 3. It's okay if you leave it there, but traditionally you'll see it written in the numerator instead. Equals x squared plus 4x plus 4. All right, so our leading coefficient is now 1. Now we can find b divided by 2, all of that squared. So b divided by 2, so 4 divided by 2 squared, that's really 2 squared. So that's our completed the square constant. Then we need to add and subtract. All right, -7/3y equals x squared plus 4x plus 2 squared. That's our perfect square trinomial that we will factor in the next step. Don't forget we had a plus 4, and since we added 2 squared, we've got to subtract 2 squared. Now we have a perfect square trinomial that we can factor. So the -7/3y, just along for the ride till the very end. So that equals x plus 2 squared. And then 4 minus 4, that's going to give us 0. So we could write plus 0 here, or we can just not write anything, because adding 0 doesn't really change our equation at all, right? All right, so we're almost there. Remember, this is our goal. So the only thing we need to do is get this y by itself. Now up here, we just had to multiply by the denominator, right? But here it's a little different. We need to multiply by the reciprocal, because if I have -7/3, I need to multiply by something that will give me 1. Well, let's see what happens when we do the reciprocal. -3/7, that would give me 21 over 21, which is really just 1. So whenever you have a fraction, you can multiply by the reciprocal. All right, so we're going to multiply by -3/7, multiply by -3/7. So our final answer in vertex form would be y equals -3/7 times x plus 2 squared. Now we can find the vertex, graph using symmetry. Now, the vertex here is a little different, right? We know it's going to be -2. But what's our k value? Well, it's 0, right? We just didn't write the plus 0. So that would be the y value of my vertex. All right, so that is it for standard to vertex form. Go practice.